Good morning, everyone. In the last lecture, we were discussing Nyquist plot, Nyquist criteria basically. There are some points related to Nyquist criteria. First, if the number of zeros of GSHS located in a specified region is in S plane is Z, and the independent variable S is varied along a path closing the boundary of such a region in clockwise direction. The corresponding change in the argument or phase of GSHS in GSHS plane is minus 2 pi z. If the number of zeros of GSHS in a specified region in S plane is Z, and if no pole is there inside this specified region, and the independent variable S is varied along a closed path making a boundary of such region, the specified region, in clockwise direction, there is a focus on this clockwise direction. There is a focus on this clockwise direction. If it is in clockwise direction, the sign will be negative. Sign of the phase will be negative. And if it is in anti-clockwise direction, then the sign of the phase will be positive. Or in other words, if it is in clockwise direction, phase will be negative, and if it is in anti-clockwise direction, phase will be positive. Right? So the corresponding change in the argument or phase of GSHS in GSHS plane is minus 2 pi z. Minus 2 pi z. Right? Second point, if the number of poles of GSHS in a specified region in S plane is P. In S plane is P, and S makes a boundary of such region in, again, clockwise direction. In clockwise direction, the corresponding change in the argument, the corresponding change in the argument is plus 2 pi p. Look at this point. Here also the boundary is in clockwise direction, but the angle is positive. And I told you here, if the clockwise direction is there, then phase will be negative, and if anti-clockwise direction is there, then the phase will be positive. But here the clockwise direction is there, but the angle is positive. How it is possible? It is possible because here we are considering zeros and here we are considering poles. Here we are considering zeros and here we are considering poles. Zeros gives positive angles, positive phase. Poles gives negative phase, and negative phase and here also negative phase makes this positive, and positive phase and negative phase makes this negative, right? So the angle will be plus 2 pi p, right? And if both poles and zeros are there, third case, considering Z zeros and P poles of together, located inside a specified region, specified region located inside a specified region in S plane being varied along a closed path, making the boundary of such a region uh, in clockwise direction. The mathematical expression for corresponding change in argument for corresponding change in argument is given as change in argument is equal to 2 pi p minus z. 2 pi p minus z. And this is the relation which is given by principle of argument. That change in argument is equal to 2 pi p minus z. Change in argument is equal to 2 pi p minus z. Right? There is a table which shows that if I have change in argument and if I have number of poles, then how can I find the number of zeros? Then from this formula we can say that if I have change in argument and if I have number of poles, then obviously we can find Rz, right? So let's make the table. Variation of independent variable, or simply variation of S along closed path SA, SB, SC, SD to SA. Corresponding shape of GSHS plot and final conclusion. So first we have a diagram like this. Here we have a pole and we have 4 points. This one is SA, this one is SB, this one is SC, and this one is SD, and S is traversing this path in clockwise direction. In clockwise direction. Here number of poles is equal to 1. Number of poles is equal to 1. Now, the corresponding plot of GSHS is like assuming like this. This one is GSA, HSA, GSB, HSB, GSC, HSC, GSD, HSD, and the graph is like this and in this direction only, like this. So what we see in S plane, a closed path encloses a pole. In S plane, a closed path encloses a pole, and the direction of the closed path is clockwise, right? And the corresponding plot in GSHS plane shows the closed path encloses the origin. The closed path encloses the origin, right? Here the closed path encloses the pole, and here the closed path encloses the origin, right? If this is the condition, if the two diagrams are given, how can I find the number of zeros? I don't know the number of zeros enclosed in this closed path in S plane. For finding this, we have the formula: change in argument is equal to 2 pi p minus z. 2 pi p minus z. Here we have p is equal to 1, and from this diagram, this plot, what we see, the change in argument. If I draw this vector, then this vector moves from here and like this, it is coming to this point only. And what is the angle it is making? It is making an angle of 2 pi. It is making an angle of 2 pi, but since it is in clockwise direction, therefore the change in argument is minus 2 pi is equal to 2 pi. P is 1 minus z, or minus 1 is equal to 1 minus z, or z is equal to 2. So there are two poles enclosed, sorry, two zeros enclosed by this closed path. There are two zeros enclosed by this closed path. Now, let us consider if I have this diagram, and let me have number of poles and number of zeros enclosed by this path. Then how can I draw this diagram? How can I draw this diagram? From change in argument is equal to 2 pi p minus z, what we have? 2 pi multiplied by 1 minus 2. So it is equal to minus of 2 pi. Minus of 2 pi. Right? It means the plot in GSHS plane, the closed path in GSHS plane will move clockwise since it is minus 2 pi. It will move clockwise, and how many encirclements will be there around the origin? How many encirclements will be there around the origin? N into 2 pi. N into 2 pi. What is the value of n here? 1. What is the value of n here? 1. Right? It means there will be one encirclement around the origin in GSHS plane. There will be one encirclement around the origin in GSHS plane. Right? The next condition is the diagram is like this. We have two poles and the specified region is SA, SB, SC, SD, and the direction of flow is like this. Right? Direction of flow is like this. This is the S plane, and in GSHS plane, let the diagram is like again in the anti-clockwise direction, and it is GSA, HSA, GSB, HSB, GSC, HSC, and GSD, HSD. Now again, this vector rotates one time, means number of encirclement is 1, but the angle of change in argument is plus 2 pi, because it is in anti-clockwise direction, and therefore this will be 2 pi is equal to 2 pi. What is the number of poles? P here is equal to 2, so 2 pi multiplied by 2 minus z, and from here we see that 1 is equal to 2 minus z and z is equal to 1. Therefore there will be 1 0 inside this closed path. There is 1 0 inside this closed path. Right? The third condition is if I'm having SA, SB, SC and SD and no pole or 0, no pole is inside this, right? And here if the diagram is like, it doesn't mean that if this situation is there or if this situation is there, the diagram in GSHS plane will be like this. It doesn't mean. It means if this is given in S domain and if there is 1 0 included in this closed path, then this will be the diagram in the GSHS plane. Or if this diagram is given and this diagram is given, then Z will be 1, right? Similarly here, if the diagram is like this, G S A H S A G S B H S B G S C H S C G S D H S D, right? And let here the direction is clockwise and here the direction is anti-clockwise. And look at the diagram. Since there is no encirclement around this origin, then the change in argument will be 0. The change in argument will be 0. No pole is there inside the specified region in S plane, then P will be 0 and obviously Z will be 0. It means if there is neither pole nor 0 inside the closed path in S plane, in GSHS plane there will be no encirclement around the origin. There will be no encirclement around the origin, right? One more case is there. Oh. SA, SB, SC and SD, and the direction is clockwise, assuming P here is 2 and let here the plot is like like this. The plot is like this and the direction is like this and the points, assuming here we have GSA, HSA, here we have GSB, HSB, here we have GSD, GSC, HSC, and here we have GSD, HSD. Now, what is the change in argument? Or what is the number of encirclement around the origin? There are 2 encirclements around the origin, and if I find the angle of argument, what will be the angle of argument? Change in argument. Change in argument will be 2 pi into 2. It means 4 pi, and the direction in sign of the change in argument will be positive, since it is in the anti-clockwise direction. So this will be positive. There are two poles inside the specified region in a plane. Now this will be like z is equal to 0. Z is equal to 0, right? So in this way, by using Nyquist criteria and principle of argument, we can find the number of encirclement, change in argument, and number of poles and number of zeros, right? In the next video, we will move to the next topic, which is application of Nyquist criteria to determine stability, right? So thank you.